Okay, here we go. It is arithmetic sequences that we're going to look at today. And so you've seen this formula, or if you haven't, here's a formula. You're like, what? What's this formula? Well, let me move ahead real quick before we talk about the formula. We see a sequence, we know 2, 4, 6, 8, right? We all know that. And so see these little dots, the little 3 dots at the end after 12? That means that the sequence just keeps going on and on and on and on. And wonder if somebody asked you, hey, what's the 50th term in this sequence? Well, you could spend a lot of time going, okay, let's see, 10, 12, 14, 16, 18. It just would take you a long time, right? But this formula helps to answer questions like that. So let's go back to the formula. When we see a sub n, this means we're looking for a term. For example, if we saw a sub 3, that would mean we're looking for the third term. And if we're looking for the third term, it's the answer on this side that will give us what the third term is. If we saw that we had a sub 5, that means we're looking for the fifth term. And so over here, a sub 1, it means the first term, right? When I say sub, it means that number 1 is in the sub position, right, below that A. D stands for the common difference. N stands for the term number, and -1 is just -1. So this is our formula, and we're going to learn how to use this today. So let's look at our sequence that we all know, and let's see if we can answer some of these questions. What is the third term? Well, 2, that's the first term. 4 is the second term. The third term is 6. That's the third term. Now, what is a sub 5? A sub 5, that's just another way of saying fifth term. So what's our fifth term? We've got 1, 2, 3, 4, 5, 10 is our fifth term. Then this says, what term number is 12? So that means we're going to look at, just dropped my eraser. That means we're going to look at 12 and decide what term number it is. Once again, our 2 is our first term, that's our second term, third, fourth, fifth. 12 is our sixth term. So that is just a little bit of how we're defining terms and term number. But let's go ahead and see if we can use that formula. So what if they asked us to define our sequence using the explicit formula? So that means this formula right here. Now on the test, you'll be given this. And so we don't have to worry about memorizing it right now. Whoa, that really distorted it, didn't it? All right, and so what we're going to do is we're just going to plug and chug. See this a sub n? No matter what, we are going to be writing that. That's like, when we write an equation of a line, we write y equals or f of x equals. A sub n is always going to be how we start our formula every single time. See this a sub 1? That means my first term. So I look in the sequence and I see that 2 is my first term. So guess what? That's what I'm going to put next. 2 comes next to my formula. See that plus? I'll bring that plus down. See the D? So the D is our common difference. And so it's kind of logical. What is the common difference between all of these numbers? What's the difference between 2 and 4, and 4 and 6, and 6 and 8? And you can see that's 2, right? It's going up by 2. So D is going to be 2. Now, I see a parenthesis, I write a parenthesis. We're going to stop and talk about D in just a second, but let's just keep going. See this N? N is like, to give you like something to compare it to, if we're talking about f of x equals 3x plus 2, right? See how f of x is always going to be there in our formula, and x is always going to be in our formula? Well, unless we have like f of x equals 10, but that's another story. Same thing here with n. N is always going to be in our formula. We don't have to plug anything in for that. Same with the minus and same with the 1. So when you look at it, what did we have to plug in? We had to plug in our a sub 1, right? And we had to plug in our D. Those are the only 2 things that we plug in. Those things that were in the black, and everything else we just copy from the formula. All right, so this, let's take away the yellow. What we wrote, right? what we wrote right here, this is our formula. If they asked us on the test to find the explicit formula for the sequence, we would be done. Let's talk, though, a little bit about that common difference. And so common difference, you could use logic. You can look at a sequence and just say, oh, it's going up by 2s. And so, or if you don't feel like thinking and you just want to do something just habitual, right? What always works is this. Look at any term, like 6, and subtract the term that comes before it. So 6 minus 4 is 2. That's your common difference. You could use another one. You could use 12. If I use 12 and I wanted my common difference, I'm going to subtract the term before it, and that gives me 2. All right, let's try this again. So we've got a new sequence, and we want to define it. And of course, we're going to use our formula, right? And so what we're going to do, we know that when we start, we're going to start with a sub n, right? We know we've got the next one as a sub 1. This one is my a sub 1, so that goes there. And now I just need my d. Now we've got to be really careful here. We don't want to put that plus. See the formula over here? See how it has the plus d? Well, sometimes d, okay, come on. Sometimes d is going to be, it really doesn't want to expand, does it? Sometimes d is going to be negative. So let's not jump to putting that plus in there. Here, let's move this here to remind us what we need to include in our formula. So let's look at d. If you look at it logically, we can see that all these terms, each one of them is going down, right? It's decreasing. And how much is it decreasing by? Well, 12 minus 3 is 9. 9 minus 3 is 6. 6 minus 3, right, is 3. And so 3 minus 3 is 0. So we know our d is negative 3. We don't want to put, I mean, you could put this, but look, we don't want to do that. Plus minus, that's just a minus. So we're going to put our d is minus 3. And then we just recopy the formula. So once again, we could have found our d by taking any term, like our 3, and subtracting it by the term before it. That would give us our d. All right, so when you see this on the test to find the explicit formula, all we know is we're going to use our formula, find our a sub 1, find our d, and put those two things in and leave everything else alone. Okay, we're going to stop here, and you're going to do sequences number 1 on Delta Math and just practice writing explicit formulas for sequences that they're going to give us. All right, and then come on back. All right, so we are back. Now this is asking us to find the 25th term of the sequence. Now once again, if we had all the time in the world, we could just keep going and do this by hand, right? It looks like it's going down by 3s. Do you agree? 10 minus 3 is 7, 7 minus 3 is 4, 4 minus 3 would be 1, 1 minus 3 would be negative 2. But come on, do we really want to do this all the way to 25? I don't. So what we're going to do is we're going to use our formula. And then, you know, so far all we've done is write a formula, right? Write our explicit formula for the sequences that we've been given. But now we're going to use it. So first, before we can use it, we've got to write it. I'm going to pull up some hot pink, or maybe that's really called magenta. So let's see what you think it is. So here we go. We've got a sub n is a sub n. And then we've got our a sub 1, which is 10, right? Our d, we could either just see that it's going down by 3s, and we know that our d is negative 3, or we could take our 7 and subtract 10, and that's going to give us negative 3. We're going to rewrite the rest of it. Okay. Now note, when we use this, well, we'll get to that in just a second. All right. So now this, normally we're done here, right? But they're asking me to find my 25th term. So 25th term, now we're going to write something for our n. We're going to write a sub 25. This means the 25th term. And what we're going to do is every time we see n, we're going to plug in 25. So we're going to plug it in there so we know that we're seeing our 25th term, and we're going to plug it in here. And so what we're going to do is we're going to be really careful. Do not make the mistake and say, oh, 10 minus 3 is 7, and 7 times, no, we're not going to do that. What we're going to do is either, you can take your time and do it by hand, right, distribute that negative 3. No. Let's just go ahead and pick up our calculators, let our calculators do the work, put this in exactly as you would. Oh, and I got to pick up my calculator. And okay, I don't have a calculator in front of me. All right, let me pause and come back. Okay, so I picked up my calculator after I finally found it, and I got negative 62. All right, let's see what comes next. All right, we've got a sequence, and they want us to fill in the next three terms. We're really going to use common sense here, right? We can see that we're going down by threes, right? We're going up by threes. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. Oh, you can't see that in yellow. 17. 17 plus 3 is 20. And 20 plus 3 is 23. So you're going to see something like this on the test. And it's fine to use logic when you can, right? Math is logic, right? So the common difference, once again, we're just going to take any term we want and subtract the term before it. So 8 minus 5 is 3. Or it's that number that we've been going up by this whole time. Okay, explicit formula. Once again, we know our formula. If we forgot, it's right there in front of us. We know that our first term is 5, and our common difference is 3, and then we put that n minus 1. So you'll see something like this on the test, and now it seems pretty straightforward. Okay, we're going to stop, and we're going to do delta math sequences number 2, and then when you're done, come right back to this video. We've got one more section to do. See you in a second. Okay, now you're back. We're still doing sequences, and it's just going to look a little different because we're seeing a table right now. And so we can find the common difference the same way we'd find the slope of a linear function. And, let me just pause here real quickly. When we look at, I don't want to confuse anybody, but when we look at arithmetic sequences, they're very similar to linear equations. The only difference is that when we graph a sequence, we would just see like our first term could be 1, we'd see a dot there. Our second term, let's say we're going up by 2s, right? We'd see a dot here, and then our third term, right, we see a dot there. So our sequences, if we were ever to graph them, are just little graphs of dots. If we had a linear that we were graphing, right linears always are connected. But I wanted to show you that real quickly because when we talk about common difference, it's a very similar idea as when we talk about slopes or rate of change, same word, right? So two different words, same thing. We actually can use our knowledge of slopes to find the common difference when given a table. So once again, this is just a table. This tells us what term we're looking at, right? What term number. And this gives us the answer to the term. Okay, that's the term itself. So for instance, if I were going to write this normally, I'd say, okay, 5 is my first term, right? My first term is 5. I don't know my second term. I don't know my third term. My fourth term is 17, right? Don't know my fifth term. I'm running right into my table. And then my sixth term is 25. So instead of writing it this way, like I just did in purple, they're writing it in a table. And that's okay. We can handle a table. And so we're going to use the same method as how we find slope. We're going to use the hoop method. So we're going to start at the bottom of the table. And I realize normally we do hoops like this, right? Well, we can't. There's nothing there. But we're allowed to skip. We're allowed to say 25 minus 17, okay? So 25 minus 17 is going to give us an 8. Do you agree? And then 6, since we jumped 2 on the right, we got to jump 2 on the left. 6 minus 4 is 2. Now, if we were finding the slope of the rate of change, right, we would do the 8 divided by the 2. The common difference is the same way. We're going to do 8 divided by 2 equals 4. Now, if you don't believe that that's true, let's just try 4 and see if we end up filling in this table in a correct way. Now, we're going above and beyond right now, okay? Nobody asked us to do this, but on the test, if you're doing the table one and you're not sure if you got the right common difference, just do what I'm going to do in just a second. All right, here we go. If the common difference is 4, that means we're going to go up by 4s. So 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4, yay! 13 plus 4 is 17, so that's good. 17 plus 4 is 21, and 21 plus 4 is 25. That tells us we have the right common difference. It's 4. And by now, we're so good at explicit formula, we can do this in our sleep, right? We know a sub n equals the first term. The first term is 5. Our common difference is 4, and then we just tag along that n minus 1. Woo, we're getting so good. Okay, let me check on time. Okay. All right, you rent an apartment that costs $1,000 per month the first year. I'm going to stop right now. I'm going to make this into a sequence because I know we're in sequences, right? So $1,000, that's going to be my first term in my sequence. All right. But the rent is set to go up $140 per year. All right, let's just have fun. How much would my rent be the next year? We'd add 140 to this. We'd have 1,140, right? We'd keep going, They didn't ask us to do this. I wanted you to see that. All right, what would be the monthly rent during the 10th year of living in the apartment? Well, I can't find the 10th year until I define it, right? We've got to use that little formula down there. So here we go. Let's define it. My a sub n is equal to my first term, which is 1,000, plus, now they gave us our d, which is pretty cool. It's going up 140 per year. Remember per, that should sound familiar. That's like rate of change. Well, the per tells us what our common difference is. Our common difference is the 140, which goes there. And then we tag along our n minus 1. Okay, the bell rang, so I'm going to speed it up real quick. We want to know the 10th year. That means we want to know the 10th term. This is our first term. The first year we pay 1,000. The second year we pay 1,140. The third year, right, we add another 140 to that. So if we want to know our 10th term, we're just going to plug 10 in wherever we see an n. Then we're going to pick up our calculator and we're going to put this part into our calculator, make it do all the work for us, right? All right, I'm picking up my calculator right now. All right, I got 2,260. That's kind of expensive rent, don't you think? That's a dollar sign, by the way. That doesn't look like a dollar sign, does it? All right, hopefully your calculator got that as well. 2,000, and that's not a dot there. 2,260. Yeah, hopefully we moved before it got to be that expensive, right? So the 10th year, 2,260 in rent. All right, let's do one more of these. Jeremiah starting to plan. He's going to be training for a race. So he needs a plan, I guess. In the first week of his running plan, Jeremiah will run 6 miles. See that first? That's giving us our first term in our sequence, okay? The plan calls for Jeremiah to increase his weekly mileage by 2 miles every week. So if he runs 6 miles first week, how many is he going to run the second week? That's right, 6 plus 2 is 8. How many the third week? Right, he's just going to be going up by 2s. We love this. Meaning it keeps going. If Jeremiah sticks to the plan, how many miles would he be expected to run during his 8th week? Now, 8 is so small, we could just keep doing this by using logic and keep adding 2. But I have a feeling your teachers will want to see your, still want to see some work. So we can do it. So let's just show that work. So here we go. Let's define it with our explicit formula. We've got our first term is 6. Our D is 2, right? They gave us our 2 miles every week. So that's our 2. And then we put in that n minus 1. And then we're trying to find our 8th week. I wonder if on the test it said the 80th week, right? We need to be able to do this. So the 8th week is a sub 8. And we're going to plug in the 8 for n. And then we're going to pick up our calculator or do it by hand. It should be 20, right? 8 minus 1 is 7. 7 times 2 is 14 plus 6 is 20. So gosh, his 8th week of training, he'll be running 20 miles. All right, so not bad per week. You may want to pick up the pace a little bit. What kind of race was he running anyways? All right, I'm putting too much detail into it. This was fun. Thanks for joining me. All that you have left to do is your Delta Math sequences number 3, and then do the sequences practice on paper, and you will be ready for either the test or the retake. All right, thanks for joining me.